All right, so I'm going to talk a little bit about testing. Testing, which is an often neglected when you're a student, but extremely important when you're a student, and especially when you're, I shouldn't say especially, it's really important all the time aspect of programming. I would argue if you're not testing, you aren't solving a problem. So the general strategy for solving a problem is, right from the beginning, having some sort of a plan for proving to yourself that indeed you've actually solved the problem. You have to establish a criteria to show that the problem has solved. So given some sort of input, you need to produce some output, and you need to show that this output is correct given this input at the very minimum. And just thinking to yourself, my logic is infallible, is not the way to go. So you always need some sort of a plan for proving to yourself and proving to other people that your program is correct. And generally, a test plan would be a written document, but usually there are automated tests as well, or scripted tests, meaning it's maybe a storyboard that a person is supposed to go through to make sure that your program does what it's supposed to do in the right situation. It says how many times and with what data you have to run in order to thoroughly test it. It's been proven by a guy named, I think, Hoare, that not sure if it's been proven. It's pretty much impossible to 100% test your code. I mean, imagine that your program takes as input 3 numbers, and each one of those numbers is 16 bits. Well, that means that if you consider all the possible inputs, that's a very small amount of input. All the possible inputs, you have 2 to the 48th different possible inputs. And, if you pluck up a calculator and you ask it, what is 2 to the 48th power? It is equal to 2,800, well, not 2,000, 2.815 times 10 to the 14th. 10 to the 14th. 1 and 14 zeros. Right? So we're looking at a 2 and 14 zeros plus. That's how many different test cases you would have to provide. This is beyond the trillions. So it's pretty much impossible to try to go through every possible set of inputs and make sure that the outputs match. I mean, if you did have such a mapping, you'd have the program anyway. So it's really hard to actually think about thoroughly doing it. So there's different criteria that people will have. One idea is just to come up with enough test cases, combinations of input and output, to make sure that you hit every line of code. So all lines of code execute. And what does that mean? So if I'm going in and I've got some sort of a decision where it can either be this block of code or that block of code, I need to make sure that the decision goes both ways in my program. I need to make sure that this guy gets hit and that guy gets hit, right? So that's 100% coverage would mean all lines of code. That would be 100% code coverage. And believe it or not, that's actually pretty ambitious. Often when you're testing, you don't get 100% code coverage, but that would be a good goal. And then, so this is sometimes called, so this code coverage means that every line of code, you just choose enough inputs, not all of them, you can't do all of those, but you choose enough that all of your lines of code execute. Now, if you don't have that, you can look for data coverage. So this is called sometimes white box. Sorry about that, white box testing, because you're looking inside the box and seeing the code. You imagine your program is wrapped up in a box. Data coverage just says we're not looking at the box, we're just looking at characteristics of the input and the output. So that might be a case of you just think about, you try to guess what the test cases are. You could just give it 100 random. And in my experience, random is pretty good. And you'd think, oh, if I just give it a bunch of random data, I'm likely to cover it. Random doesn't necessarily actually match real life. Sometimes you could try to probe the boundary. So we got boundary, if I can write it out. Boundary cases. B-O-U, there we go. So boundary cases are maybe when each number is less than 0, equal to 0, greater than 0, right? And if you imagine that there's some characteristics of your problem, maybe you have to do something with an empty list, or you have a maximum of 1,000, so you might want to test it 999, 1,000, and 1,001, just to probe what happens to your algorithm right around the edges, kind of natural special values of your input and output, without necessarily knowing how the code was written. And this is called black box because you can't see inside. So this would be black box testing. Very often in your computer science, your programming classes, your assignment may or may not come with some sort of a black box test that the instructor uses as a sanity check, because we don't even, it's pretty hard to read code and figure out if it's correct. So your instructor might provide you with example test cases but hold a few out, and then have special extra cases that do this type of testing before you even look at the code, so that before we even look at the code, we have some indication that it's right or wrong. And then we can look at the code, and then we see, this condition doesn't look right, and then we can come up with a new test case based on your code that breaks it. So that's the fun of being a professor. So there's a plan, so you have a test plan, and then you have to somehow implement the plan. So one way is you can have a script, have like another program whose sole purpose is to run your program and check the input and the output. Or you can have a person that does it. There are programs you can go and grab. So one of the things that I like to do is I like to write console programs, and the reason I like to write console programs is because they're very they're very easy to script out. So you can write some sort of maybe a batch or a shell, if you're on a Linux type of system, script to test your program at the console. Also, there are things called unit tests. You kind of harness your code itself so that it can be run in a program, and they give you nice reports that say this case passed and that guy didn't pass. And these are really done professionally. These are good for testing little pieces of code, and then, but to test the whole program, you might have an integration test, would be something like this. And there are also GUI automation tools, which you can download and run. And these are very useful also if your program outputs a log file. So you could maybe have, you can record yourself doing something that should produce a certain result, and you can verify that it produces the output. There's a program called SICULIX, something like that, if you guys want to Google it. It's a nice GUI automation framework that's free, and you can verify that the GUI, by the way, is the graphical user interface with Windows, etc. It's kind of hard to automate those because you have to click on the button, and if you resize the window, that button is in the wrong place. So yeah, it gets a little bit tricky, but there are tools to support it.